Hello and welcome, fellow coders. Thank you so much for joining me today on this 7th part of my golang tutorial series. It is a real pleasure teaching you, you in particular. And I sincerely hope that you are as excited as I am to learn about arrays. Arrays are basically one of the most important data structures that you need to learn. So definitely make sure to check out this video all the way until the end, so you don't miss out on any tiny detail. But now enough of this pretty face and let's hop right into the code editor. To create an array in Golang, you start off by typing into square brackets. Every array has a predefined size n and a predefined type t. A more specific example would be to define an array with size 2 of type integer. To see how this array looks like, let's go ahead and print it out. Let's also go ahead and print out the size of the array. You can do that by using the len function, which returns the length of its argument, in our case the size of the array. The console output shows us that indeed the array has size 2 and is filled with 2 elements of value 0, which is the default value for integer variables. If you want to set the value of an element within an array, you can use the square bracket notation as well. Just put in the index at which position you want to change the value, followed by an equal sign and the value you want to store. In our case, you can see that if I put in the index 1, it actually changes the second element within the array. That is because the first element within an array gets stored at the index 0, the second element at index 1, and so on and so forth. This behavior seems kind of strange, I know, and you should definitely keep it in mind. Alrighty, now that we know how the indexes work, let's go ahead and try to store a value at an index that is greater than the size of the array. You can see that my IDE is already complaining that the index 2 is out of bounds, but just for the giggles, let's go ahead and run the code anyways. Well, to no surprise, we get an error. I just wanted to point your attention to the index out of bound error message. Since you will see it all the time, you now have a good clue of what you probably did wrong. Okay, so let's go ahead and store the value at index 1 again. As you can see, you can use the square bracket notation to store values into an array, but you can also use it to get values out of an array. By running the code, you can see that the element at index 1 is indeed 4. To sum it up, by using the square brackets, you can set values in an array and get values out of it. But let me now show you a different way of how you can define an array. You can also define an array as a literal by appending two curly brackets like this. This will also create an array of size 2 filled with 2 zeros per default, which you can see when running the code. One cool thing is that if you define an array using the literal notation, you can prefill it with values within the curly brackets. See, printing out the array shows us that the values 1 and 2 are set as elements within the array. This is actually a pretty useful and short way of defining and filling arrays if you know what values it will hold. But this notation has one small, well, let's call it drawback, or one thing that might pique your interest. By writing it like that, you might already see that we are defining the size of the array twice, once in the square brackets in the front and the other time by adding 2 elements in the curly brackets. Even though this might not seem like a big deal, you would still have to adjust the size within the square brackets every time you would add another value. Lucky for us, Golang provides us with a way to prevent that. And that is by using 3 dots within the square brackets. This way, instead of explicitly setting the size, Golang's compiler will implicitly figure it out during the compilation process, which of course takes up a tiny bit of time and computation power. For small arrays, this does not make much of a difference, but for larger ones, this can become an issue. Just for you to keep in mind. In Golang, arrays are kind of special compared to other programming languages in the sense that in Go, arrays are values. Many other programming languages like C, C++ or Java treat arrays as references. In Go, that's not the case. Now, what do I mean by that? If you create a new variable b and store the value of a into it, you would assume that both variables hold the same array. Well, this is actually not the case. Let's see what happens if I change the second element in the array b and print both arrays to the console. In before mentioned languages, the array a would also have changed because they treat arrays like references, meaning that both arrays point to the same location in memory. In Go, as you can clearly see in the output, b is a whole new array. What happens under the hood is that if you create a new array and store the value of another array into it, Go creates a new array and copies all the elements into it, so it actually creates a whole new copy. This is also true if you pass an array to a function as an argument. Since I'm coming from the Java world, this was actually quite confusing in the beginning and led to many bugs in my code, so definitely make sure to keep it in mind. Anyway, even though we haven't spoke about pointers yet, there is one way to create a new array without creating a copy, and that is by using the address of operator in front of the original array. This will not create a new array and copy all the values into it, but rather store the reference of array a into the variable b. This has the consequence that if you change an element in b, the element in the first array a gets changed as well. But in general, arrays in Go are values, so make sure to keep this in mind. Another very cool thing about arrays is that you can actually store arrays into arrays. To show you that, I'm going to comment out these lines because I will need them later. Now let's go ahead and define two arrays holding two strings each. The array that will hold the arrays will also be of size 2 and will hold two arrays of size 2 and type string. Again, we can use the curly brackets to take the first two arrays and pass them in as elements. To actually get the values out of the array, we can use the square brackets of the lines array. This will give us the array line 1, and using the square brackets again, we'll return the first element of the first element, which should be the string 11. Running the code shows us that that is actually the case. Cool. Now let's go ahead and remove all of that and bring this part back in. I'm going to remove the address of operator and run the code again to remind you of the fact that arrays in Go are values. So changing the element of array B at index 1 does not affect the array A. I'm going to need this in a few seconds, so please bear with me. The second way of storing multiple values of the same type in a single variable are slices. Arrays and slices are kind of used in the same way, or let's just say that they serve the same purpose of storing elements in a sequential manner. But you have to remember that they are completely different types with special use cases and sometimes completely different behavior. Do not worry though, I will of course show you all the differences, but first let me show you how you can define a slice. Honestly, it's super simple because all you need to do is to remove the size within the square brackets of the array definition. And there you go, you created a slice. Slices, compared to arrays, do not have a preset size. They are dynamically sized, which is one of the biggest advantages they have over arrays. So whenever you want to store something within an array or a slice and you do not know the number of elements beforehand, in most cases you want to use a slice. But now comes the tricky part. Slices, not like arrays, are treated as references. So if you take the same code as before, only changing the array to a slice, you can see that after changing the element of B, the element within A got changed as well. Thus, A and B are pointing to the same address in memory. Trust me, while I was learning Go, this was one of the things that really drove me crazy. I was confusing slices and arrays all the time, since they basically look the same, right? But their behavior can be so much different, so always make sure to check whether or not you are using an array or a slice. When you are trying to create a slice out of another slice, there are a couple of ways you can do that. Of course, you can simply store A into the variable B as we have seen before, but you can also use the almighty square brackets again and simply put a colon in between. This will make more sense in a few seconds, but for now, this is completely identical with the example before. It creates a new slice with all the values from its parent A and stores them within the variable B. We can now go ahead and create another slice and use the square brackets notation again. This time though, we are going to put in the number 4 in front of the colon. What this does is, it will create a slice and put in all the values from parent A, beginning from the 4th index all the way to the last element. Again, remember that indexes within arrays as well as slices start with 0. As you might have already guessed, of course this also works by putting in the number after the colon sign. This will create a slice and fill in all the elements from the beginning up until the 4th element, but not including it. So D holds all the values from indexes 0, 1, 2 and 3, which corresponds to the values 1, 2, 3 and 4. Obviously, you can also go ahead and combine the upper two and create a slice holding the values beginning and ending at the certain index. To check out all the values of the newly created slices, let me quickly go ahead and print them all out. This will make it a whole lot more clearer to understand. Starting with B, you can see that it holds the exact same values as A. C, as expected, holds the values beginning with the 4th index up until the end, which are the values 5 to 9. The values for D are also the ones that we have expected, starting from 1 up until 4. E holds the values starting from index 2 up until but not including the index 4, so the values E actually holds are 3 and 4. This is an awesome and easy way of creating sub-slices out of parent slices, but beware of the fact that all these slices still point to the same memory address where A is stored, so changing a value within each of these slices, for instance A, will affect the elements of all the other slices. C, by changing the value of the first element of A to 99, all the other slices that contain the first element of A now have their values changed as well. Knowing this is super important. There is actually another way of creating slices in Go, and that is by using the built-in make function. Make, as you can see, takes a type as its first argument and size as its second. Don't bother about the 3 dots in front of the int for now, I will explain what this means later on in this tutorial. Just remember that you can use the make function for slices, maps and channels, and the second argument is used to define their size. Since I want to create an empty integer slice, I'm going to put in the type slice of int and 0 as its size. To print out the length of the slice, I'm going to use the len function again. But there's actually another very important metric that arrays and slices have, and that is their capacity, which can be retrieved by using the cap function. The difference between length and capacity is fairly easy to understand. Imagine your slice being a bucket that you can fill with apples. The capacity of your slice is the number of elements the slice can hold at max. So basically the maximum number of apples the bucket can hold. Let's say for instance 10. The length of a slice is the number of actual elements within the slice, or in case of the basket, the number of apples within it. Let's say 5. I think it's fairly easy to understand that the capacity always has to be higher or at least the same number as the length. Otherwise, your bucket would hold more apples than it theoretically can, which would be a pretty awesome bucket, I have to admit. But unfortunately, this does not exist in the real world. I hope the analogy makes the difference more clear. When running the code, we can see that the length as well as the capacity of our created slice is 0, which is kind of no surprise. If we go ahead and change the size within the make function to 2, we will get a pre-filled slice of length 2 and capacity of 2. The values are both 0, which again is kind of no surprise. So why do I make such a fuss about the length and the capacity? Well, let me explain. First, I need to show you how you can add values to a slice. Since a slice has a dynamic size, you cannot simply use the square brackets notation, but instead you can use the append function. The append function takes a slice as its first argument. This is the slice where the values will be appended to, and the second argument is going to be the values you want to append. Again, do not pay too much attention to the 3 dots for now. It is simply showing that you can put in more than one argument, but they must be of the same type. And lastly, the return type of the append function is a slice. This is why I store the return value of the append function into a slice a again. So a will now hold the appended integer 1. To see this in action, let me quickly copy and paste all the print statements after appending 1 and execute the code. Now that is odd. We appended only one number. So the length of the slice is 3, which makes total sense. And looking at the slice itself, it contains the first 2 zeros and the appended number 1. But why the heck is the capacity 4? Well, this is because of the way how slices work and go. Under the hood, slices consist of arrays. Let me walk you through what is actually happening right here. First, we originally created an array of size and capacity of 2. Let's take the bucket analogy again. Imagine we went to the store and bought ourselves a bucket which can hold exactly 2 apples, put it into our yard and filled it with 2 apples. That is what happened when we first initialized the slice A. Then we wanted to add a third apple, but we weren't able to fit it into the bucket. So we went to the store again and bought a second bucket of double the size of the first one. So a bucket which can hold up to 4 apples. Then we went back to our yard and took all the apples from the first bucket and put them into the second larger one. And finally, we added the third apple. That is more or less how golang works with slices and the reason why the length is 3 and the capacity is 4. So whenever the underlying array of a slice is full, golang creates a new array of at least double the size, copies all the elements from the original array into it, and then appends the next element. It is not guaranteed that the new array always has double the capacity. It can be more than that, but never less. As you can imagine, if you append to a slice often enough so that golang needs to create and copy new arrays a few times, all the copy processes can take up quite some time. So as long as the slices are small, the copy processes are fairly cheap and fast. But if the slices get bigger and bigger, golang has to perform a lot of copy processes, which will in the end take up more and more time and slow down the performance of your code. The good thing is though that we can add a third argument to the make function which will create a slice of specified capacity. So in our case, we have a slice of length 2, capacity of 100 and containing 2 elements of value 0. If we would add 98 more elements, the capacity would still be 100, but adding the 99th element would now force Go to create a new array of capacity of at least 200 and copy all the values from the first array into the new one. This one creation and copy process is fairly cheap compared to many smaller copy processes. So if you know that your slices will become large, it is a good practice to create slices with a predefined capacity that is large enough so that not many copy processes need to take place. Okay, and that is it for appending to slices. Now let's go ahead and remove some stuff from them. First, let's go over the 2 easy cases. If you want to remove elements from the beginning of your slice, you can use the square brackets again. It actually works the same way as if you were creating a new array. So simply put in the number before the colon at which index you want your slice to start. And since we are storing the new slice right into A again, A will now have lesser elements than before. Or more precisely, all its previous elements starting from the first index or the second position respectively. See, A now contains the values 2 all the way up to 5. And as you might have already guessed, removing elements at the end of the slice is done the same way. Simply change the number after the colon to remove elements from the slice at whichever position you want to. If you want to remove the last element, one cool trick is that you can actually use the len function to get the length of the slice, but make sure to reduce its number by 1, since the indexes of slices start by 0. This statement will always remove the last element, no matter what size the slice actually has. And to no surprise, A now only contains the values 1 to 4. Cool, isn't it? Okay, removing elements from the beginning or the end is easy, right? Now the fun part, because removing elements in the middle of a slice is a whole different story. But before I start explaining how it works in detail, a quick spoiler. I will be using the append function in conjunction with creating subslices, so basically combine all the things we learned so far. Okay, now let's begin. The first thing I'm going to define is the index of the element I'm going to remove from the slice. You will see why I put it into a separate variable in a second. I'm going to use the append function to immediately store the slice with the removed element right back into the original slice A. As you might remember, the first element of the append function is the slice to which the element should be appended to. Since we want to remove the value at the specified index, we create a subslice beginning from 0 up to index. The second argument of the append function are the elements that should be appended. In this case, these are all the elements after the specified index. So all we need to do is again use a subslice. This subslice should start from index +1 all the way to the last element of the parent slice. But we kind of ran into a problem now. Hovering over the second argument, the code editor tells us that we cannot use a slice as an argument. If on the other hand we simply would append more numbers like that, it would work just fine. But how do we obtain the numbers of slice A so that the append function is happy? If we have a look at the documentation of the append function, it already gives us the solution to our problem. We need to make use of the 3 dots after our slice. What happens is that the 3 dots kind of unpack the elements. So instead of passing in the slice, the arguments will get passed or processed as a series of numbers. Kind of in the same way as we would pass each number individually, like we saw before, right? Cool, so the compiler is happy now, and we can go ahead and run our code to see if it really removes the element at the specified index. This seems to work. The element at index 1, which is the number 2, got removed from our slice. Awesome. Oh, and by the way, functions with arguments using the 3 dot syntax, like for instance the append function, are called variadic functions. Just for reference. Whew. That was a lot of information. I sincerely hope you enjoyed watching this video, because I surely did creating it. And you know the drill, right? Hit the like button, smash the notification bell, and subscribe to the channel if you're new. Until next time, keep on coding!